Hey, Sunshine. So we have two triangles here. We have some information about them. And we're going to prove that point G is the midpoint of segment DT. So we're going to use triangle congruence, and then we're going to use something called CPCTC, which I'll get into in a minute, to show that G is the midpoint of segment DT. So CPCTC stands for corresponding parts of congruent triangles are congruent. So if I already know the two triangles are congruent, then I can say that any two pieces are congruent. The CPCTC proofs are using a little bit of backwards logic here. We're saying we want to prove that G is the midpoint of segment DT. So the definition of midpoint is that it breaks the segment into two congruent pieces. So to prove that it's the midpoint, I want to prove that these two pieces are congruent. So I don't know that yet, so I'm not going to mark them as congruent, but I'm going to put a little dot next to them so that I remember that's my goal. Now, because triangle DOG is a rotation of triangle TAG, I know that if I can prove that the triangles are congruent, then I would be able to say that the two segments are congruent to each other. So to start off, I need to prove that my triangles are congruent. So I'm going to start with my given information, which conveniently in this proof are actually congruent pieces. That's a pair of sides and a pair of angles. And as I put them into my proof, I'm also marking them in my diagram to show which segments I'm using. So segment DO and segment DA are corresponding sides of those triangles. So now I have two pieces of information. I've got one pair of sides and one pair of angles. So I know I'm not using side, side, side because I've got a pair of angles. So now I need to find one more piece. I'm looking at, it could be any of these. So I want to find, do I know anything about the sides? I want these sides congruent, but I don't know that they're congruent. I don't really have a reason for these two to be congruent because I don't know anything about the segment, but I have a pair of vertical angles. And so that's a nice, easy peasy way to get a pair of congruent angles into my proof. So when I name my vertical angles, G is the vertex of both angles. Since there's more than one angle here, I have to use a three-letter name, but G is the vertex, so G has to be the middle letter of the name. So OGD. If I said angle DOG, I would be talking about this angle up here. So it's important that you're really careful about what order you put your letters in when you're giving angle names. And then, of course, they are true because they are vertical angles. And vertical angles are always congruent to each other. So that's another pair of angles. I've got a pair of sides over here. I've got an angle here and an angle here. And I always have to double check and make sure that the things really line up. It's side, one tick mark angle, two tick mark angle. Side, one tick mark angle, two tick mark angle. It's important that they match up in the correct order and that you don't have, if it was this angle is congruent to this angle instead of this angle, then it wouldn't work out. When you do side angle angle, you have to be really careful about the order of the angles themselves to make sure that the pieces actually line up. But they do, so I've got my side angle angle, so I can say that my triangles are congruent. So when I make my triangle congruent statement, because this isn't, the goal of this proof isn't to prove the triangle is congruent, that's just a step along the way, I have to actually construct my triangle congruent statement. So I can write the first triangle in whatever order I want to, but I have to make sure that the second triangle matches. So if I start with D, then the second triangle I have to start with T, because that's the corresponding angle. And then O corresponds to A, and then G corresponds to G. Also, this time I wrote side angle angle, whereas over here I have angle angle side. They are the same thing. You can write SAA or AAS when you're doing the proofs in ALEX. it gives you a drop-down list, so you just choose whichever one they say. But I believe I have seen it in both orders in different resources. It doesn't matter if you're giving me handwritten proof, or if you're doing it out for yourself, you can write it either way, and I won't fuss. So now I want to use that information. I want to say that the two segments are congruent because these two segments are corresponding sides of triangles that I already proved are congruent. So I can say that the corresponding parts of congruent triangles are congruent. So CPCTC. So when you're doing proofs, triangle is congruent to triangle. The only acceptable reason is these 5. Then after that, you're usually going to have a CPCTC. So you're going to have whatever statements it takes to prove the triangle is congruent. You have to have 3 statements of congruent segments and or angles, and whatever it takes to support them. So in this case, we had nice, straightforward ones. 2 of them were given, and one of them was vertical angles. So we didn't need a supporting information. In other proofs, sometimes it'll have statements, and then you need to say, okay, because by definition of midpoint, or because the lines were parallel, or whatever. So sometimes there's extra statements supporting these pieces, but you have to have all 3 of these before you can say the triangles are congruent. You have to have the triangles are congruent before you can say CPCTC. So the order in proofs is very, very important. But now I'm not all the way done. I want to prove that G is the midpoint of DT. And so now I've shown that these segments are congruent, and that is the definition of midpoint. So now I can say that G is the midpoint by definition of midpoint. So definition of midpoint is used to switch between these 2 statements. If I gave you this, you would say this using definition of midpoint. If you have this, then you can make this statement saying by definition of midpoint. It works in both directions. And so now we have finished our proof. We showed that G is the midpoint of segment DT by using CPCTC after proving that the pair of triangles was congruent.